Ever pondered over what makes C++ a powerful programming language? Welcome to the journey where we'll explore the depths of C++, a language that has been the backbone of many software systems around the globe. From operating systems and web browsers to databases and graphics, C++ has been at the heart of it all, shaping the digital world as we know it. Why, you ask? Well, C++ offers a unique blend of features that provide programmers with a high degree of control, efficiency, and flexibility. This versatile language combines the power of low-level programming with the convenience of high-level abstractions, making it a popular choice for both beginners and seasoned developers. In this video, we're going to break down the key features that set C++ apart. We'll explore objects and classes, encapsulation, data abstraction, inheritance, polymorphism, modularity, and more. So strap in for an exciting ride. Stay tuned as we delve into the fascinating world of C++. To start off, we must understand objects and classes, the fundamental building blocks of C++. Let's dive into the world of objects and classes. Imagine a blueprint for a house. The blueprint itself isn't a house, but it contains all the necessary information to build one. In the realm of C++, a class is like that blueprint. It's a user-defined data type that encapsulates data and functions. A class lays out the structure but doesn't contain any actual data. Now let's consider an actual house built from the blueprint. That house is an instance of the blueprint. In C++, an object is an instance of a class. It's a real-world entity that contains actual data. An object is created from a class, and we can create as many objects as we want from a single class. So why are objects and classes so important in C++? The power of these concepts lies in their ability to model real-world scenarios. For instance, if we're building a video game, we might have a class for character. This class could define attributes like health, strength, and speed. We could then create numerous character objects, each with their own unique set of attributes. Moreover, objects and classes form the backbone of object-oriented programming, OOP, a programming paradigm that C++ is widely known for. OOP allows for code reusability and makes the complex software development process more manageable. Objects and classes also lay the foundation for other key features in C++, such as encapsulation, inheritance, and polymorphism. These features further enhance our ability to create robust and scalable software. In a nutshell, understanding objects and classes is like learning the alphabet before writing a novel. Without a solid grasp of these concepts, we would be hard-pressed to leverage the full potential of C++. With a grasp of objects and classes, we can now explore more complex features. Next up, we have encapsulation and data abstraction. Diving into the world of C++, we find two pillars that uphold the structure of this programming language: encapsulation and data abstraction. These two features are like the secret agents of C++, working behind the scenes to protect and hide data. Let's start with encapsulation. Picture a capsule, a small container that holds something inside, protecting it from the outside world. Encapsulation in C++ does exactly that. It wraps up the data and functions into a single unit called a class, effectively hiding the data from outside interference. This is like your personal diary, where you encapsulate your deepest secrets away from prying eyes. Now, why is this essential? Well, encapsulation enhances security. By restricting direct access to data, it prevents accidental or unauthorized modifications. You wouldn't want someone accidentally changing your high score in a game, right? Encapsulation ensures that the only way to modify data is through methods provided by the class. Next, let's discuss data abstraction. This feature is all about simplicity. It allows us to represent complex systems in a simplified manner. Think of it as looking at a smartphone. You don't need to know the intricacies of how every single component works to make a call or send a text. You just need to know which buttons to press. Similarly, data abstraction hides the complex details and provides us with a simple interface to work with. This makes the code easier to understand, modify, and even debug. It's like having a clean, organized desk where you know where everything is, making your work more efficient. In essence, encapsulation and data abstraction are the unsung heroes of C++. They work silently, ensuring our data is safe and our code is clean and simple. They are the key to creating robust and efficient programs, helping C++ stand tall amongst other programming languages. Encapsulation and data abstraction thereby contribute to the robustness of C++. Inheritance and polymorphism, two vital features that give C++ its flexibility. Let's start with inheritance. Imagine you're crafting a beautiful piece of jewelry. You start with a basic form, say a simple ring. Now you want to design several variations of this ring. Instead of starting from scratch each time, you use the original ring as a base and add or modify its features. This is what inheritance allows in C++. A class, known as the child, can inherit the properties and methods of another class, known as the parent. This promotes code reusability, as common functionalities don't need to be coded again and again. Now let's talk about polymorphism. The term comes from Greek words poly and morph, meaning many, and forms respectively. In the context of C++, it refers to the ability of a function or an object to behave in multiple ways. There are two types: compile-time polymorphism, including function overloading and operator overloading, and runtime polymorphism, which is achieved through function overriding and virtual functions. Polymorphism is like a chameleon, adapting its behavior based on the situation. Together, inheritance and polymorphism enable dynamic behaviors. Inheritance allows us to build upon existing structures, adding new features or redefining old ones. Polymorphism, on the other hand, allows these structures to behave in various ways based on their data or state. Imagine you've inherited that basic ring design, but now you want each ring to sparkle differently. Polymorphism allows you to define a common function, sparkle, in the parent ring class, and then override it in each child class to create unique effects. In essence, inheritance and polymorphism are like the tools of a master jeweler, allowing for endless creativity and efficiency. They are key to the vast capabilities of C++, enabling you to craft intricate, efficient, and flexible code. Inheritance and polymorphism are key to the vast capabilities of C++. Let's round off with abstraction, modularity, constructors, destructors, and data binding. Abstraction is a pillar of object-oriented programming. It is the process of hiding the complexity of the system and presenting the user with a simplified view. Think of it as the dashboard of a car. You don't need to understand all the inner workings of the car to drive it. You just need to understand the controls on the dashboard. That's abstraction. Next up, we have modularity. Modularity is a design technique that separates the functionality of a program into independent, interchangeable modules. Imagine building a house with Lego blocks. Each block represents a module. You can easily add, remove, or replace any block without affecting the rest of the structure. That's the beauty of modularity. Let's move on to constructors and destructors. A constructor in C++ is a special function that is automatically called when an object of a class is created. It allows the programmer to set initial values for object attributes. On the other hand, a destructor is a special function that is automatically called when an object is no longer in use or goes out of scope. It's commonly used to free up resources that the object may have acquired during its lifetime. Now let's discuss data binding. Data binding is the connection bridge between the program and the data. For example, when you create a variable and assign a value to it, you're binding that value to the variable. In C++, we have two types of data binding, static and dynamic. Static binding happens at compile time, while dynamic binding happens at runtime. These features collectively make C++ an immensely powerful language. By understanding these features, you can write efficient, structured, and functional code in C++. So, keep practicing and happy coding. So, there you have it, the key features that make C++ a favorite among programmers. We've journeyed through the core concepts, starting with objects and classes, the building blocks of C++. We've delved into encapsulation and data abstraction, highlighting how they help us maintain the integrity of our data and simplify complex systems. We then explored inheritance and polymorphism, showcasing their roles in creating flexible and reusable code. Lastly, we touched on abstraction, modularity, constructors, destructors, and data binding, tools that enable us to manage complexity and improve efficiency in our coding processes. Each of these features plays a crucial role in shaping the power and flexibility of C++. They collectively contribute to making it an efficient, robust, and versatile language, suitable for a wide range of programming tasks. With these features at your fingertips, you are now ready to harness the power of C++.